Well, here we are back again doing some more geometry lessons. And I have my camera focused on the Braille book right now. And also can move my print book into place. We are going to cover 3-1 angles in the geometry concepts and applications done by Glencoe Mathematics. In this section, you're going to learn how to name and identify parts of angles. So we have built up our skills through Chapter 1 and Chapter 2 with learning about points and lines and rays and non-collinear points and collinear points and midpoints and betweenness and distances. Now we're going to start to put some of that information together to learn about angles. And we have some different vocabulary things going on, especially in this first section. The first one is opposite rays. Are two rays that are part of the same line and have only their endpoints in common. So there's a tactile on page 90. That's where section 3-1 begins. And there's a drawing right at the top of your page. And it's a line. On the left, they've labeled the arrowhead Y. And on the right, they've labeled the arrowhead Z. And then in the midst of it, they have a point X. It's kind of interesting that they don't have points at Y and Z, and they've just chose to label the arrowheads. It would have been more appropriate to have points. But they're saying that X, Y, so you get the point of betweenness in the middle of Y and Z, X, Y, and then XZ are opposite rays. And so that's kind of a, no-brainer, to be frank. Remember, a ray has to have an end point, and then it goes into infinity in one direction through another point. So if you start at X right in the middle and then go to the left through Y, you could have a ray XY. And then if you start at X and go to the right, you'd have a ray XZ. So the figure is formed by opposite rays is also referred to as a straight angle. So when we have a point in the middle and then just extending to the left and the right, a line is also a straight angle. And a straight angle, we're going to learn here in a few moments, is 180 degrees. It's just flat and it's open all the way, and so it's 180 degrees. There's another case where two rays can have common endpoints, and this figure is called an angle. And so if you turn the page in Braille, print, we're just the next paragraph down, on page 90A, A90, says there is another case where two rays can have a common endpoint, and the figure is called an angle. So if you take a look at the tactile on this page, in the midst of it, there are two rays, one extending through about the 2 o'clock position and the other one extending through about the 4 o'clock position. The vertex is labeled where those two rays come together at the left, and it's at point S. They have it right below it, labeling it point S. In the midst of that, those two rays, in the middle of it, they have a label 1. That's how you can label an angle also. And then when you go through the 2 o'clock position, they're going through point R. That's called a side. That's the side of your angle. And when they're going through the 4 o'clock position through point T, that's also a side. So that's kind of the anatomy of an angle. Some parts of angles, they have special names. It says in the paragraph, the common endpoint is called the vertex, and the two rays that make up the angle are called the sides of the angle. And there are several ways to name the angle. And I think they're going to talk about those on the next Braille page. Yes, on the next Braille page, B90. And and they're going to tell you the different methods to name angles. And so the first method, method 1, it says to use the vertex and a point from each side. And the vertex letter is always in the middle. So from that drawing that we just looked at, remember, if you look at it again, you could turn back and look at it again. You had R as a point, and then you had S as your vertex, and T as a point. So what they're saying is you could name that angle with S always in the middle because it's your vertex. You can name it two ways. You could name it angle RST or angle TSR. Okay, RST or angle TSR. Okay, and notice that in Nemeth, ED and the less than, well, ED, sorry, not the less than, ED OW is the angle indicator, and it would say that, and then capital R, capital S, capital T, or you could have the angle indicator ED and OW, and then you'd have capital T, capital S, capital R. That would be one way to label their angle. In print, you use a symbol that kind of looks like an angle, a little miniature angle, and you just put the capitals right after it. So you have this miniature angle looking kind of thing, kind of pitched at about 60 degrees. And Brailler's, I'm drawing that right now for print users. And then you have capital R, capital S, capital T, or you could do the angle indicator and capital T and S and R. Remember, the biggest deal is remember that your vertex is always in the midst of it. Okay, the middle point. All right. Another way to name an angle is just by the vertex only. So if there's only one angle, and it's the only angle at that vertex, then you can name it by its vertex. So again, this drawing, if we turn back Braille users to look at our drawing, we have a vertex and they labeled it point S. And in print, if you look back at that drawing, they label it point X. So you'd still use the same angle indicator, an ED and an OW, and then the capital S in Braille. Or in print, you would just use your little angle symbol and then a capital S, or whatever they call the vertex. Also, another method, you can name it by the number. They put a number amidst the angle. So in this drawing, they had a number 1, very close to the interior of the vertex of the angle. So we could name it angle 1. So again, you'd use your angle indicator and then a 1. So ED, OW and a 1, or in print, your angle indicator and a 1. All right. So little code for geometry on how to name angles, and it's important to do it correctly. Otherwise, if you're reading in a story problem and didn't quite have the letters in the right order, you could get confused as to what's the vertex, what are the points of the sides for the rays. So we have a definition of an angle. We're Euclidean geometrists, remember, and so we have lots of definitions and postulates and theorems in order to establish all these rules and be able to do more things. And so we have a definition of an angle. In words, an angle is a figure formed by two non-collinear rays that have a common endpoint. And then they give a model, which is our drawing. And we have a drawing here with a vertex of E. It heads off the ray from ED is off into about 2 o'clock position, going through point D. So we have ray ED. And then EF through about the 4 or 5 o'clock position is our other side. They're also labeling the interior of the angle at the vertex 2. So we could label this angle. You learned you could use all 3 points. You could say it's angle D, E, and F, or angle F, E, D, or you could name it by its vertex only, angle E, or by the point in the interior of the angle, not the point, but there's the label. You could say angle 1, angle 2. Now that's not a measurement. That's just a symbol or a name that they're using for the angle. It's not 2 degrees. You're going to learn that later about the degrees. So we now then move on to an example for naming angles in different ways. So Braille users, turn the page to your next page. It's page 91, straight up. It says example 1. Print users, you're on page 91. And the example is asking us to name the angle in 4 ways and then identify its vertex and its sides. So we again have a graphic. Print users, it's slightly to the right. Braille users, it's in the middle of your page. We have point A up at about the 11 o'clock position, and that angles down to about the 5 o'clock position through our vertex B, and then goes through the 3 o'clock position through point C. And then they've labeled the interior of the angle 1. So to name this angle, we can do it using the 3 points in 2 different ways. We could say angle A, B, C. We always got to include B in the middle because B is the vertex. Or we could say angle C, B, A. We could name it just by its vertex, angle B, or by the number that was placed in the interior of the angle to label it. And we could label this one, angle 1, I believe it's called. I might have said angle 2 earlier. Sorry about that. It's angle 1. All right. So then they give us some practice with a your turn. So Braille users, turn the page to A91. Print users, we're looking at little letter A at the left of example 1. We have an angle that they're representing here in graphic form. It has a vertex E up at the top close to the 12 o'clock position and slightly angled off of that to the 7 o'clock position through point D. So we have a ray ED. That's one of our sides. We're talking about the anatomy of our angles. And then go back to the vertex E and go through point F at about the 4 o'clock position for ray EF. That's another side. So we know we have a vertex E and we have our 2 points, D and F. And they've also then labeled the interior of our angle with a 2, a number 2. So to name this angle, how would we name this angle? You can pause the video for a moment and figure that out. Name it in 4 different ways, and then also name its vertex and its sides. And I kind of helped out with some of that. All right, and we're back. And you should have named it from its points. You would have named it angle DEF or angle FED, making sure that the E is always in the middle because it's the vertex. You could have named this angle by its vertex, angle E, or named it by the number that they printed in the interior of the angle. You could name it angle 2. Now take a look at the tactile at the bottom of Braille page A91 or just to the right of example 1 in print. And you have a point G at about the 9 o'clock position with an arrowhead, and then you immediately go east through 3 o'clock and you end up at point H. And then from H you go just to the left of 12 o'clock, between 12 and 1 o'clock through point I. And in the midst of your angle, in the interior of your angle down close to point H is the number 3. So you need to name this angle in 4 ways and identify its vertex and its sides. Go ahead and pause the video and do that, and then hit play and we'll go over those. All right, and we're back to identify the 4 ways to name the angle and then the sides and the vertex. So we'd name it by its points, angle GHI or angle IHG. We could also label it based on its vertex only. So we could say angle H or the number that's labeling the interior of the angle, and we could label it angle 3. The sides are ray HG. Notice I start with our end point at the vertex H and go through the point G into infinity. And then another ray HI, and our vertex is H. So that's some practice at naming angles in 4 ways and their vertex and their sides. Braille users, if you turn the page to B91, B91, print users, we're looking down at the next paragraph. And it states to look at the figure at the right. And Braille users, you have the figure down below. 3 angles have P as their vertex. Whenever there is more than one angle at a given vertex, use 3 points or a number to name an angle as shown. So we can't name this angle P because we actually have 3 angles. So let's take a look at this drawing and discuss those 3 angles. We have, if you feel down at about the 9 o'clock position, there's a point M, an arrowhead and a point M, and then you go through horizontally to the vertex of P. From P, you can go through the 10 o'clock position, follow the ray up through the 10 o'clock position through point N. Go back to your vertex P, and then also then follow the ray through about the 2 o'clock position through point O. They've labeled 2 of the angles. The one on the left, so using side PM and PN, they've labeled the interior of that angle, angle 1. And then the one to the right, using ray PN and ray PO, they've labeled that angle, angle 2. Now the 2 angles together, angle 1 and angle 2, and combined together, they use the sides of the ray PM and then the ray PO, and that creates one very large angle, which they did not label with a number. It was not possible to do that. So there are several angles going on here that we could name. We could name angle MPO or OPM. We could label angle MPN or NPM. Or we could label angle NPO or OPN. We could also label angle 1 and angle 2 for the 2 smaller angles. And that's it. We can't say angle P because angle P is, vertex P is being utilized for 3 angles. You can only use the vertex to name an angle if it's only labeling 1 angle. All right, so example 2, Braille users, if you turn the page to example 2 on C91, print users, we're looking in the midst of page 91 in example 2. We have name all angles having W as their vertex. So we have a tactile, a graphic again. W is up in kind of the top right corner, and that's your vertex. And slightly to the left is a ray, WX. That's one of your sides of an angle. Then go back to your vertex W, and through about the 8 o'clock position is ray WY, through point Y. Go back to your vertex W, and then go immediately down through the 6 o'clock position through point Z. You have ray Z as another side. Again, you should recognize that there's 3 angles here. There's a very big angle, and then there's 2 little angles making up those big angles. Those are called adjacent angles. You'll learn that again later. And they've labeled the top angle, I'll call it, they've labeled that angle 3 on the interior of it, and they've labeled angle 4 for the bottom angle. So we could name the 3 distinct angles with their vertex. So that means we're going to use the vertex as their middle point. So the big one we could name angle XWZ, or we could name it angle ZWX. Then we could name the little angles, like angle 3 and 4, we could name them XWY, that would be angle 3, or we could go backwards and label it YWX. And likewise, the angle 4, we could label YWZ or ZWY. Always using that W point, that vertex point in the middle between the two ray points. All right. And can we label an angle that's named angle W? We can't. We cannot do that. All right, so then they have us practice. Your turn. So Braille users turn the page again to D91. We have two drawings on this page. We have little letter C and little letter D to practice in the Your Turn. So we're going to take a look at little letter C at the top. It has a vertex point of W kind of down in the bottom left corner. And if you go immediately to the right, you go through a point C. So you have ray WC. If you come back to the vertex W and go immediately up through the 12 o'clock position, you go through point A. So for ray WA. And then if you go back to the W position, you'll find another ray going through about the 1 o'clock position through point B. In the midst between the side WA and WB, they've labeled that angle 1. And between ray or side WB and WC, they've labeled it that angle 2. So we could name these angles in all sorts of ways. We could name them angle 1, angle 2. We could name the big angle, angle AWC. And how else could you name all these angles? So you give it a try. Pause the video for a moment, give it a try, and then start it up again. All right, so how else did you name these angles? Did you name them backwards? The big angle would be CWA, or angle 2 could be named CWB, or angle 1 could be named BWA. Those are different ways we could name these angles. In little letter D, we've got 4 rays going on here, creating 4 angles. Well, no, more than 4 angles, really. We've got a big angle, we've got 3 little angles, we've got 2 angles coming together to kind of make a medium angle, and another 2 angles coming to make a medium angle. So we have 5 angles going on here. Vertex W, again, is the vertex. It's at the top left. We're going to have 4 rays going off of vertex W. I'm going to do the first one going down, slightly through about between 6 and 7 o'clock through point R. So you have ray WR. And they labeled next to it number 3 because the angle formed right there on that between WR, ray WR, and WS, which is the next ray to the right, going through about the 5 o'clock position. So those two sides are forming angle 3. And go back to W and go through about the 4 o'clock position, and we're going through point T, so we have ray WT, and the angle right there in the middle forms between ray S and ray T. They're labeling angle 4. And then finally up top they have ray WU, and it's forming, that's a side with a side of WT, that's forming, they're labeling angle 5. So we could name all sorts of angles on this particular drawing. Pause the video for a while and name it, at least 4 of them. All right, so what did you find to label? Let's see, you found obviously your numbers, angle 3, angle 4, angle 5. But you also would have angle RWS, or you could name it backwards, angle SWR. You could have RWT. See how that creates an angle? RWT, 2 sides. Or S or T, R, TWR. Excuse me, TWR. Or you could have RWU, the very big angle. Or you could name it backwards, UWR. Then you could start over at S, about the 4 o'clock position, and you could name the angle SWT or TWS or SWU or UWS. Then you could move to the T point at about the 4 o'clock position. You could name that TWU or UWT. Lots of choices here for angles. Right, Braille users, turn the page. There's a big paragraph of information on the next page, E91. It's also a drawing that's attempting to show what they're trying to discuss here. So it says, in the print users, you're at the bottom of page 91. There's a drawing to the right. It says, an angle separates a plane into 3 parts: the interior of the angle, and the exterior of the angle, and the angle itself. In the figure shown, point W and all other points in the blue region, so Braille users, they've kind of sort of, the blue region is like this light textury feeling. All points in the blue region are in the interior of the angle. So that means they're on the inside, underneath your rays. Point V, so point V is up in the top left-hand corner. Point V and all other points in the yellow region, so this area is not textured for Braille users, are points in the exterior of the angle. So they're on the outside of your ray and vertex. They're in the exterior. Okay? And then the angle itself is obviously X, Y, Z, or Z, Y, X. So you create your angle with the 2 rays. On the inside of the rays, underneath the rays, is the interior of your angle. On the outside of the rays, or above your rays, or to the exterior of your rays, is the exterior of the angle. It's important to remember that anatomy for our angles. So turn the page, Braille users and print users. We're on page 92. Braille users, you're at a page break, and right on page 91, F, 92. And there's examples, and it says to tell whether each point is in the interior, exterior, or on the angle. So number 3 has 2 rays. They haven't labeled it. They've just put these 2 rays, and then there's a point in the midst. Now, is that on the inside of your angle or the outside of your angle? And point D is actually on the interior, because it is underneath or between our rays. So point D is in the interior. If you turn the page, Braille users and print users, look at example 4, immediately to the right of example 3. You have 2 more rays creating an angle, and there is a point that is on one of our rays. So that would be on the angle. It's neither in the interior or the exterior. It's on a ray, so it's on the angle. And then number 5, it's kind of hard. You got to be very careful reading this. We have an angle. It almost looks like a right angle, but they don't have an indicator for it. And they have a point. You have your left ray there, and they have a point F just to the left of that left ray. And that's actually on the outside of our angle, on the exterior part of our angle. It's not going to be sandwiched in between our rays. Okay, so that point is on the exterior. So now they have you practice in your turn on little letter E, F, and G. Braille users, you'll have to turn the page again to B92. And we have little letter E, where we're looking at an angle, and it looks like they've labeled the vertex R, and they're asking what that point is. Is it on the interior, exterior, or on the angle? And of course, if they've labeled a point right on the vertex, it would be on the angle. In the next problem, little letter F, they have 2 rays, and they have a point S, if you can find that. Where is that located? On the interior or exterior of the angle? It's inside. It's underneath your rays, so it's on the interior. And Braille users, if you turn the page to C92, you get 2 rays for little letter G. They have a point, T. And that is where? Is that on the interior or exterior of your angle? Let's take a look. falls inside underneath your rays, so it's on the interior of the angle. All right? So that is lesson 3-1, angles. Starts to get you familiar with how to label them, how to identify whether points are on them or on the interior or exterior. Being very careful to use the vertex appropriately when you label angles. You always use it as the midpoint when you're using your 3 points. It's the one in the middle. You can only use the vertex point if it's just labeling one angle. And that's it until lesson 3-2. You want to do some extra practice, take a look at pages 92 and do at least number 92 and 93 and do at least number 1 through 8. Till the next lesson, keep thinking and using your math brain.